This assignment deals with using the laws and properties of logarithms that we've been looking at to simplify and then to estimate a value for a log. For instance, with the first one, I've given you the log base 10, right? It's not specified, so it's base 10. Log base 10 of 12, 8, and 7. You have approximate decimal values for those. And then the goal is to use these values to estimate the value of log base 10 of the fraction 7/8. So, the way that you're going to go about that is you're going to use our property about the log of quotients. So we're going to be able to say that log of 7/8 is equal to log of 7 minus log of 10, or sorry, 8. Okay, and remember, we can do that because when it's a quotient like this, when it's a fraction, we can just do the difference of the two logs. Now, we know from right here that log base 10 of 7 is 8/10. Okay, so this is 0.8, approximately speaking. We know that log base 10 of 8 is 9/10. So we can subtract 9/10. All right, well, 8/10 minus 9/10 is negative 1/10. So there we go. An approximate decimal value for log of 7/8 is negative 1/10. Okay? We're going to employ this strategy over and over with these other exercises. I'm going to skip down to number 3. Okay? So I've given you log base 10 of 12, 7, and 8. And you're going to find log base 10 of 64, an estimate for its value. All right, well, we don't have a fraction, so we don't want to think about doing a difference like we did for the first one. We want to think about, okay, well, how can we factor 64? Well, 64 has several factorizations, but the one that's going to be helpful for us involves 8. 8 times 8 is 64. So I can break this into log of 8 plus, there we go, log of 8. Because 8 times 8 is 64. So I know log of 8's approximate value is 0.9 or 9/10. So that means that I can just add 9/10 and 9/10. And that'll give me an approximation. So 1.8. So the log base 10 of 64 is approximately 1.8. So there we go. Now, there will be times when you'll have to work with your numbers a little bit. Case in point, number 2. If you look, you see I've given you log base 10 of 12, log base 10 of 8, and log base 10 of 7, none of which are factors of 2 or 3. So it's not really helpful knowing these if this fraction stays as 2/3. But if you think about scaling your fraction, multiplying both the top and the bottom by 4, then we could come up with the equivalent fraction 8/12. Okay? So what we want to think about then doing is not log of 2/3, but log of 8/12. Okay? So now we've got both of these numbers on our list for estimates, and it's a fraction, so we'll treat it the same as we did the first one, and we'll break it into log of 8 minus log of 12. of 12. All right, so log of 8 is 9/10, and log of 12 is 1.1. So we're going to do 0.9 minus 1.1, which is negative 2/10, or negative 0.2. Negative 0.2. And there we go. So there's our estimate for number 2. Okay? And so that's how you'll proceed with this. If we look further into the assignment, you'll notice that beginning with problem number 7, I changed the base from base 10 to different bases, and that is significant. All right, if you think about it, for number 7, 330, you're looking for log base 3 of 330. Well, a factorization, there are several factorizations of 330, but one of them involves 3. Well, actually, they all involve 3, but it involves 3 and 10 and 11. So when you go to do this, you're going to break this up into log base 3 of 3 plus log base 3 of 10 plus log base 3 of 11. Wow, that's getting sloppy. So then you'll be able to add 1, because log base 3 of itself is 1, with 2.1, because we know that log base 3 of 10 is 2.1, and also 2.2, because we know that log base 3 of 11 is 2.2. So that's going to give you a total of 5.3 for your estimate. Okay? So that's how you'll proceed with these. If you have trouble beyond that, just get in touch with me.